next convergence test is called the comparison test. For the comparison test, we start with two series, a sub k and b sub k, that need to have positive terms. And there are two things that we're going to look at. The first one, if 0 is less than or equal to ak, which is less than or equal to bk, and we know that b sub k converges, the series b sub k converges, then that means our series a sub k also converges. We have something that adds up to a finite number, and then a sub k is all smaller than this, so we're adding up smaller numbers, so they must also add to some finite number. The other case, if 0 is less than or equal to bk, which is less than or equal to ak, and we know the series b sub k diverges, then the series a sub k must also diverge. I now have something that's adding up to be infinite, and I have numbers bigger than that I'm adding up, so that must also be infinite. Let's look at some examples. My first one, the sum from 2 to infinity of ln k over k to the fourth. The first step is to actually figure out my comparison series. So we're going to notice that ln of k is always smaller than k, and this can be verified just by looking at their graphs. That tells me that ln of k is less than or equal to k over k to the fourth, which is 1 over k cubed. We know that 1 over k cubed converges by my p-series test because 3 is greater than 1. So that tells me that this must also converge. I now have k cubed over k to the fourth minus 6. And so when we're dealing with this, we usually want to compare polynomials to polynomials. So one thing that I can say is that k fourth minus 6 is definitely less than k to the fourth. Subtracting 6 makes something smaller. When I move to the other side of a fraction, I'm now making this bigger. So flipping a fraction switches the direction of your inequality. I can now multiply both sides by k cubed. So now I have k cubed over k to the fourth minus 6th greater than or equal to k cubed over k to the fourth, which is 1 over k. I know that 1 over k diverges, and now I have something bigger than something that diverges, so my original series will also diverge. Another example, I have the sum from 1 to infinity of 4k plus 5. It's natural that we want to compare things to other polynomials without all of the coefficients and extra terms. So I'm going to say that this is greater than or equal to k. Flipping the fractions reverses the sign of the inequality. Now I know that this thing on the right diverges. However, we have a problem because my inequality here is actually in the wrong direction. I have something smaller than something I know that adds up to infinity. It could still add to infinity, or it could be a finite number. So my test now is inconclusive. And so this test doesn't always work. And so instead we have something called the limit comparison test that is a little more efficient that we'll talk about in the next video.